All right, welcome back. And let's talk about cumulative distribution functions. So let's take a look at definition 3.5. 3.5 here. The cumulative distribution function, abbreviated CDF. Excuse me. CDF. The cumulative distribution function, we use the letter capital F of x for the cumulative distribution function of a discrete random variable. Let's say capital X again. This is derived from the probability mass function of a random variable. Probability mass function, which is, remember, denoted little f of x, is the cumulative distribution function, CDF. Capital F of x is equal to the probability that x is less than or equal to little x. Hence the word cumulative. Right? Hence the word cumulative. It's the probability that x takes on that value or anything less than or equal to it, or anything lower than it, okay? So how does one compute this? Well, you're just going to take all the values, all the probabilities that are below a certain point and add them up. You're going to add them up. We have our summation notation here. So this is going to be adding up all the PMF values where t is less than or equal to x, okay? Where t is less than or equal to x. And I know a lot of people tend to get fuzzy with this summation notation because for whatever reason, it hasn't, they never got that down quite concretely. So we'll take a look at that in this example. Consider the following. Consider the following PMF, probability mass function. Let's find its CDF, its cumulative distribution function, and let's go ahead and sketch the graph of the CDF as well. Sketch the graph. All right, so let's see here. So let me put a box around the definition real quick. That's what we're going to work with. And then here's the PMF that we're going to work with in this problem. Little f of x. So we got values 1, 2, 3, and 4. So not too many. 0.25. There's a 50% chance that x takes on the value 2. 0.125. That's an eighth. And 0.125 that x takes on the value 4 as well. All right, so find its CDF. Find its CDF. All right, we could do this. Find its CDF. All right, so think about this. Where can we start? We could start here. We can start with 1 because anything below 1 has 0 probability. So we could start with capital F of 1, okay? Now, capital F of 1, by definition here, right, is the probability that x is less than or equal to 1, all right? And in this case, that's just 0.25. Because the probability that x is equal to 1 is 0.25, and we don't get anything below that, all right? So that starting value is a little trivial. But let's keep going down the line here. The next spot where something would change would be at 2. So let's talk about f of 2. F of 2 then is the, I mean, if we want to go ahead and show you the summation here, right? This notation is going to be overkill, but just to maybe start the pattern, this is the probability then. This would be the probability that x goes from 1 to 2 of f of x. X goes from 1 to 2 of f of x. All right. This is equal to the probability that x is less than or equal to 2. I should reorder this. Let me reorder this here real quick. I am sorry. I don't know what's a pain to erase in your notes. This is the probability that x is less than or equal to 2. Okay, so how do we figure out that less than or equal to probability? We just add up the individual probabilities as x goes from 1 to 2. And so in this case, that would be f of 1 plus f of 2, which is going to be 0.25 plus 0.5. And so that's equal to 0.75. Let's try f of 3 and see if we can straighten out this pattern here, right? F of 3 then, the probability that x is less than or equal to 3, this is the sum of the probabilities as x goes from 1 to 3 of your probability mass function, little f. And so that would be f of 1 plus f of 2 plus f of 3. And so we can add all those together. 0.25 plus 0.5 plus 0.125 is equal to 0.875. And last but not least, let's take a look at f of 4. F of 4 is the probability that x is less than or equal to 4. And so that's the sum as x goes from 1 to 4 of little f of x. So that's f of 1 plus f of 2 plus f of 3 plus f of 4. And we can add all the probabilities together. A quarter plus a half plus an eighth plus an eighth is in fact equal to 1, which is a good sign when you get to the end of your probability mass function that your CDF value there is equal to 1. So these are all the individual values. All the individual values. Okay. And so we can put our CDF, capital F, in tabular form here if we want to at this stage, right? So what we could do then is we can sort of write it. Usually we'll write it like this. I'm going to have to scroll down to give myself a space here. Usually we'll write it like this. Capital F of x then is equal to, and give ourselves a big brace here. All right, so here we go. Remember, capital F is about the cumulative distribution, and it's about these less than or equal to statements. It's about these less than or equal to statements, okay? So capital F of x, I'm going to start in the reverse. I'm going to start at the end here. If x is, what do we have here? X is less than or equal to 4. So capital F of x is equal to 1 if x is bigger than or equal to 4. Okay, equal to 1 if x is bigger than or equal to 4. Okay, right? Capital F of x is equal to 0.875 if, what is it equal to 0.875? Well, x has to be at least 3, right? X has to be at least 3, because you don't jump from 0.75 to 0.875 until you add in 3. Until you add in f of 3, you don't get that jump. So this would be when x is bigger than or equal to 3. And then it's going to stay there until you get to f of 4, until you add that f of 4 in, right? So then this is going to be bounded. You have an upper bound of 4, not including. Capital F of x is going to be equal to 0.75 if x is at least 2, right? If x is at least 2, then you're going to get this f of 2 here, right? But you don't jump from 2 to 3 until you get 3. And so this has an upper bound of 3. capital F of x is equal to 0.25 if x is at least 1, but smaller than 2. X is at least 1, right? You're not going to get the 0.25 probability. You don't get this unless you get that 1. You don't get that unless you get the 1. Okay? And then so what about the rest of the function, right? Well, if x is less than 1, then the probability is 0. And that is our CDF right there. Capital F of x. Capital F of x. Okay. And let's take a look at a graph of this as well, real quick. Okay. Let's take a look at a graph of this here, because if I go ahead and draw the graph x, and now I'll put capital F of x on the vertical axis. Let's see, what are the relevant points here? 0, there's a 1, a 2, a 3, and a 4 are all interesting here. And this caps out at 1. Cut that in half, that's 0.5. So there's 0.75 and there's 0.25 for us. All right. So let's take a look at this, right? Let's take a look at this. I'm going to go through this graph actually in a different fashion. I can literally just plot this that I have in my CDF on the left here directly, right? But I also want us to think about what the CDF is in regards to deriving it from the PMF, right? In the sense that if x is less than 1, there's no probability assigned to that based on the table here. And then as soon as x gets to 1, we have a probability of 0.25. So as soon as x gets to 1, we have a probability of 0.25. So let me put that there. Now, anything below that, we don't get any probability. As soon as x gets to 1, we have that, okay? Now, looking at this, when x is 2, there is a 0.5% chance that x is equal to 2. The cumulative distribution is everything that is 2 or lower. So we would have 0.25 plus 0.5. That would be 0.75 when x is equal to 2. So 0.75, we would go right there. Would be where that is, okay? Now, think about what's in between here, though. Think about what's in between, right? Think about something that's in between. What's the probability that x is, let's say, less than or equal to 1.9? 1.9, right? Well, this is the cumulative distribution function. When x is less than or equal to 1.9, there is 0 probability that you go anything between 1 and 2 until you get to 2. There's 0 change in probability. So if x is less than or equal to 1.9, this is equivalent to the probability that x is just less than or equal to 1, right? Because you don't add any new probability. And so we're going to just include all of this here. There we go. There's that. And then this is going to have a jump, an increase and a jump. That jump, that increase right there, this jump is a jump that's a height of, that's an additional 0.5. And then from 2 to 3, nothing changes. From 2 to 3, based on our probability mass function, nothing changes. But then we get to 3, we jump up to 0.875. Should be something like that. That would be something like that. So this jump right here, this jump, that jump is equal to 0.125. That's an additional 0.125 based on this probability. And then the last jump happens at 4, and we jump to 1. And it looks like this. And there's another jump of 0.125 there as well. That is our CDF graph. It'll look like that. You get these step functions. Okay? Step functions, all right? This, what can get confusing here is people are like, what is this question about asking x being less than 1.9? Why is that just not equal to 0? Why is that not equal to 0? It's not equal to 0 because think about what this is asking. Let's apply a question. Talk about like the number of heads you're getting, right? when x is less than or equal to 1.9, that'd be saying, what's the probability you get 1.9 heads or less? 1.9 heads or less when you're flipping, let's say you flip those 3 coins like we did earlier, right? Let's say like you were flipping those 3 coins like we had way earlier over here. Less than 1.9 would just be saying you get 0 heads or 1 heads, and that still has a positive probability that you should take on. Okay? And so we get these step functions that look like that. You should be able to try to go back and forth. We can go back and forth, right? We can go back and forth from PMF's little f of x to capital F of x. Back and forth, right? Capital F of x, right? To go from little f of x to capital F of x, you're going to add everything up, right? If you're going to reverse to go from capital F of x to little f of x, what if you started with this? What if you started with this? How can I take this and derive this? You do the reverse. You take a look at the size of the jumps. To go from capital F to little f, right? You compute the size of the jumps. You compute the size of the jumps, right? So I can look at the graph here and say, look, there is a jump right here. This is a jump of 0.25. That's plus 0.2. That's a 0.25 jump. Probability that x takes on 1 then is 0.25 because that's the size of the jump. The size of this jump, the second jump right here, is 0.5. So then I can derive that probability. The size of this jump is 0.125, and I can derive that. Okay? So we should be able to go back and forth from there. All right? I'm going to leave it at that. Maybe it's time to try a practice problem or 2 and then come back and see if we have any other questions. Please post those in the discussion thread below, and we will see you in the next video.